So this next section is more applying what we learned again from last section. Okay. So there's no, I don't have notes to give you per se, but I think it's going to be helpful to work through some examples together. So you guys have, well, let's start with an easier one just to get it warmed up here. So number 1 is the first one that you have assigned to you. Now, we solved before with logs, and what we found is if you have a log on the left side and a log on the right side, you can get rid of them and set the arguments equal to each other. Now, that only works if there's one log on each side. So what you cannot do, I can't, like on number 1, I can't say, oh, I have a log 8 here, log 8 here, and log 8 here, and just get rid of all the log 8s. You'd be wrong. Can't do that. So the first goal is to make each side have only one log. And so my right side already has one log. Leave that. My left side, I got 2 logs I need to condense. In order to condense, what am I going to have to deal with first? The 1/2. So if you have a coefficient other than 1 in front of the logs, you have to use the power property to move that number. Okay, so that's the first step. Log base 8 of 5. I'm going to move the 1/2 to be the power of 9. All right. Now can I drop all the logs? No, not yet. So now I can add, well, first of all, we know what 9 to the 1/2 is. That's 3. So I could write log base 8 of 5 plus log base 8 of 3 is log base 8 of x. And then use the product property. And what do we get on the left side? Log base 8 of 15. No, don't add them. You multiply them. Once you get here, 1 log on each side, then you can use the reasoning of, well, if I just have 1 log on each side and the base is the same, then the arguments must be the same. So I can drop the log base 8 and say, well, 15 is equal to x. Why do we multiply them? It's the first property we proved, that when you're adding logs, you multiply the arguments. You don't add them. We wrote it down, and it's called the product property. No, we've proved it. Okay. Okay, let's pick one. 7 or 9? 9, okay. I heard 9. I'm not going to do both. I heard 9 first. Okay. Going with 9. Okay. So can I drop the log of both sides? Why not? The 2's in front. So we have to deal with the 2. Make it the exponent. We get log base 4 of x squared is log base 4 of 25. Now can I drop the log base 4? So we end up with x squared is 25. And then I get x is what? Plus or minus 5. Now we have to check some things when we're solving. Can the argument be negative? And if you don't remember, we took it in our notes. You can look back there, or you can think, if go back to exponential form. If you have your base to your power is equal to the argument, right? I'll just say m. Your base is positive, and it's not 1. So if you have a positive number to some power, can you get a negative answer? No. So the argument has to be positive. So in this case, we're going to be dropping the negative. Now, if I was solving for the exponent, could the exponent be negative? Yes. So you got to be careful. Some things are allowed to be negative, some things are not allowed to be negative. So in this case, we're only going to accept 5 as the answer. Okay. I can help you individually. Let's see. 15 or 17? Okay, I heard 15. I could do any evens with you. I could do any evens with you, yes. It might. So, okay, 15. What's 15? I need you to see that it's different because we don't have a log at all on one side. Okay? So, if you don't have a log on one side and you have a log on the other, you have a different method. Don't use the method if you have a log on each side, you drop the log if there's one on each side. If you have something like this, then you're going to use the definition of logs. You're going to change it out of log form and put it into exponential form. That's how you get rid of the log. So we have our base 3, we have our argument here, and we have our exponent here. And so when I change it out of log form, it becomes 3 to the power of 2 is the square root of x squared plus 17. And it looks easier now. What do we do? Okay, so this first of all is 9, right? And then we're going to square both sides. We get 81 is x squared plus 17. Subtract 17 from 81. Is it 64? I'm trusting Atticus here. It is, okay. And then we take the square root and get x is positive or negative 8. And we have to decide, can we keep them both? Raise your hand if you think yes, I can keep them both. Raise your hand if you say no, I cannot keep them both. Okay. You can, good, because even the negative, if I plug it back in, will the negative 8 make the argument negative? No. So it's okay to keep. Okay? As long as the argument itself is positive, that whole expression, then we're okay. Okay? Okay. From here on out, I will do any even problems that might be helpful to you, so, by request. Those are the only odd ones I'm going to do. Number 8. Okay, let's take a look at 8. Okay. So on 8, notice I have 3 terms. One of my terms does not have a log. And so I'm going to put all the logs on one side of the equation and everything else on the other side of the equation. Okay? So I'm going to leave the 5 natural log of e over 5th root of 2 plus the natural log of x is equal to 1. So all the logs on one side, everything else on the other. Now I'm going to work on making this piece here one log. I need to condense it. In order to condense, if you have something in front, make it the power of the whole thing. So I get the natural log of e over the 5th root of 2, all to the 5th power, plus the natural log of x equals 1. And so that's going to be the natural log of e to the 5th over 2. Because the 5th root of 2 to the 5th, the 5th roots and the 5th cancel out. Okay. So I'm still working towards one log. Now I can do what? Multiply the arguments together. So I get the natural log of e to the 5th x over 2 is equal to 1. So I multiplied the x times the e to the 5th over 2. What do you do if you have a log on one side and no log on the other side? Change it to exponential form. What would it be? What was exponential form be, guys? E, because that's the little base here, to the power of 1. So e to the power of 1 equals this whole argument. Okay? Now we just need to get x by itself. So what would you do next? Multiply by 2, and you get 2e is equal to e to the 5th times x. And next step? Next step? I want x by itself. I don't want the e to the 5th. Divide by e to the 5th. And we get x is 2e over e to the 5th. Can I reduce that? What's the answer? 2 over e to the 4th. Okay. Any other even problems that you guys would find helpful to go over? It's up to you. Okay, so I will pause and let you work, and if you do come across something and you want to ask about an even problem, we can continue doing that, okay? Other than that, you have an even problem? Okay. So other than that, I'm gonna pause it here.